All right, so 3.1 is called quadratic functions. We're actually going to start this note today and then finish it on Friday. It's like a two-dayer because there's a lot of content in it, okay? Quadratic function being parabolas. Like I said, we're about to spend a lot of time focused on parabolas and specific. So we're not just shifting using transformation anymore, okay? We're going to start to identify parts of our parabola, including the vertex, which is the coordinate point in which your parabola changes direction. It's variables, so it's an x and a y, but specifically the vertex are called h and k. The line that runs through it is called the axis of symmetry. So the axis of symmetry runs directly through your vertex so that if I folded my parabola on this axis, it would be symmetric, okay? It is a vertical line, so it's always an x equals equation. Specifically the x coordinate of my vertex. So it's always going to be x equals h. So it might ask you to find the vertex. It might ask you to plot points, draw your graph, and then axis of symmetry would always be x equals whatever the h coordinate is or whatever the x coordinate of your vertex is. And then the last thing on this graph is the minimum, okay? The minimum is the point here where your parabola changes direction. It is the y coordinate of your vertex. So this is just k, the lowest point on your graph. If your parabola flips and opens downward, then there's a maximum, but everything else is the same. This format, f of x equals ax squared plus bx plus c, is called quadratic form. So there's going to be quadratic form and there's standard form, okay? It's also referred to as vertex form, so some books call it vertex form. That means the same thing. You'll know the difference because this form has an x squared and an x, where the other one would just have an x squared. So that's the difference. It will be in standard form, which we'll get to in a little bit. Would only have the x squared. It's not going to have an x squared and an x. To graph the equation that's in quadratic form, we're going to find the vertex by doing negative b over 2a. So some people need to see it written like this. Okay, that's the same thing. X is negative b over 2a, so we're going to take the opposite of the sign that for the middle term and the value of the middle term, and then put it over 2 times whatever's on the first term. Then you get that. That's your h. You plug it back in to get the y, and you have your answer, which would be your hk. Then you're going to plot that. You're going to plot the y-intercept by plugging 0 in for x. And then you're going to plot any additional points that you might need. So we're going to say you need 3 points at the minimum to draw your vertex. To draw your graph. 1 should be the vertex, and 1 point should be to the left of the vertex, and 1 point should be to the right of the vertex. You can also use the x-intercepts would be making the y 0. All right, so we're going to start baby step our way in. We're going to start pretty easy. These just say to graph. So the first thing I'm going to do is, first of all, see that this is in quadratic and also standard form. Those are the same thing this time because there's no x to the first, okay? So I can find my vertex 2 ways with this one. One is, think about the transformations on this. If it's just x squared, is there any shift left or right? No. Is there any shift up or down? No. So the coordinate point that would be my vertex would be at 0, 0. So the transformations get you that far. But now we've got to go more specific than that. We're going to plot some extra points, okay? If we had done negative b over 2a, this would be a 0x plus 0. This is my a, and b would be 0. So if I wanted to do the x coordinate on my vertex as though negative b over 2 times a, this would be negative 0 over 2 times 2, which is 0 over 4, which is still 0. Then I would take and plug that back in, and I get y is 0. So we don't need to do it because transformations tell us that this is not moving left or right or up or down. But if you did, because eventually you will need to do negative b over 2a, that's what it would look like. Now, before today, we would just make our parabola. We would make it relatively narrow because it's got a 2 on the front, but we need to be more specific this time. This is both our x and our y intercept. So plugging in 0 for either doesn't help us get either of the other intercepts, which means what comes next is plugging in some points. So if the intercepts don't help, which it's not because it's the same as the vertex, right? And there's not enough information to plot 3 points, then I'm going to take that coordinate point and I'm going to plot 1 to the left and 1 to the right of it. So just to the left of 0 would be -1. I'm going to plug in -1. And just to the right of it would be +1. I'm going to plug in +1. I'd get 2 times 1, which is 2, and 2 times 1, which is 2. So 1, 2, and -1, 2 are coordinate points. And then I'm just going to connect them. So again, at minimum, you need 1 point on either side of your vertex. That's enough. You could have plugged 2 and -2. It doesn't matter. You should have also known that those are symmetric. So if you plot one, you can also plot the other without having to plug in. If it asked for the axis symmetry, it's at x equals 0. You need to get 1 point to either side of your vertex. So you could have picked any point to the right and any point to the left, but you need to get at least 3 points. 1, that's your vertex, 1 to the right and 1 to the left. So we're not doing transformations anymore. You got to get more specific on that. Yep.
So you could pick any number?
Yeah. So look at 2, right? 2, again, the transformations tells you that there's nothing right and nothing left, which means my vertex is at 0, 0. If I want to plug in a point to the right and to the left, you could pick 1 again. You could pick 2 if you wanted to. I could plug in 2, right? So I'd get 1/2, 2 squared, 1/2 times 4, which is 2. So at 2, my coordinate point is 2. And then I could plug in -2. It should be the same because this would be symmetric. And it is also 2. So this time we plugged in 2. You could have plugged in 1 and -1. You could have plugged in 3 and -3, whatever you want to plug in there, as long as you get 1 to the right and 1 to the left of your vertex.
Sure, so how do your vertex is 0 again?
Yeah, because there's no horizontal or vertical shift. But that's about to change.
1/2 x squared plus 2.
Now you know it moved. Yep, but that's about to change. Like, these are as basic as you can get.
Does it have to be the same number?
No, it just makes it easy so you'd know it'd be reflexive, but it doesn't need to be the same. Yeah.
So why don't they say you do y equals 2 like that, and then b equals 2a? Why'd you do that?
Because I said you could use transformations to identify your vertex this time,
Oh, that's just a fine.
but you could also do it that way. Yeah, we're going to get to the point that you can't use transformations anymore. Yeah. Like, I'm going to skip these. We'll do one of them because you'll see that it's negative, but then we'll go to the next one. So now it's a -4x squared. What do we think the graph is going to look like? Upside down and narrow again, right? But my vertex is still 0, 0. If I plugged in -1, I would get -4, -1 squared, and then +1, -4, 1 squared. I'd get -4 times 1, which is -4, and -4 times 1, which is -4. So 0, 0, and this would be -1, -4, and +1, -4. Which is, again, consistent with what we thought at the beginning. You just have to be more accurate this time. So 4, same thing. Vertex is 0, 0. This time it's going to point down, but it would be wider, right? Everybody good so far?
Can you please?
Go what? Okay. What if they're in standard form? So if they're in standard form, this again would be that there's not an x squared and an x. There's just one x visible. It could be squared by itself like it just was, or it could be with your horizontal shift, which means there'd be something in the parentheses with it. If you are doing that form, then you can identify the vertex by taking the opposite of what follows x, which would be your horizontal shift, and then the thing that's by itself, which would be the vertical shift, and that's going to be your HK. Then you can plot points left and right of it, again, like we just did. God bless you. The axis symmetry is still x equals h. Whatever's in the front here is going to affect how narrow and wide this goes, so when we plug in points, it would change that, okay? So that format looks like this. F of x equals x plus 2 squared minus 3. So tell me what you know about it based on transformations. It's left 2, right? Left 2 and down 3. So in coordinate point form, that means that my vertex is -2, -3. So if you compare it to your equation, what's after the x will always change signs because we go the opposite direction. And then whatever's by itself will always be the same. So you don't need a visual representation of that to figure that out, but if you want to do it, I would go left 2 and I would go down 3, and that's my vertex.
Can you still do the -b over 2a?
You would have to expand and FOIL that and then get AB.
Oh.
So I'd have to do x plus 2 times x plus 2, FOIL it out, and find it. It's probably more work than it's worth. Yeah. If it's in, so you're going to see these are going to be in two different forms. This is standard, and then we're going to switch to quadratic, and that's when you would do that. Yeah. Okay, so now I still need more points, okay? So one way to do this is I can find my intercepts. So to find the x-intercept, I would plug 0 in for y. So f of x is the same thing as y. This would be y equals x plus 2 squared minus 3. And then I'd make that y 0. 0 equals x plus 2 squared minus 3. And now I solve. Add the 3. Then what? Square root both sides. I have a plus and minus in front of that 3. And then subtract the 2. So I have -2 plus and minus the square root of 3 would be my x-intercepts. Oh, that's really hard to read, sorry. So -2 minus square root 3, 0, and -2 plus square root 3, 0 would be the x-intercepts. Yeah.
Does the order matter?
No. So now if I want to plot these, I have to approximate root 3, right? Root 3 we say is just smaller than root 4. So you're going to approximate it because it doesn't have to be perfect on your graph. But you could say that's like a 1.7 or 1.8 even. So I'd get -2 minus 1.7 and -2 plus 1.7. This would give me -3.7 and this would give me 0.3. -0.3, sorry. So on my graph, I'm going to go to -3.7 and I'm going to go to -0.3 and plot my coordinate points. And then I can also look for my y-intercept. And for the y-intercept, we plug 0 in for x. So I get y equals 0 plus 2 squared minus 3. Y would equal 2 squared minus 3. 4 minus 3, which is 1. And now I just connect those dots. Vertex is the opposite of what follows x, and then whatever's out by itself. So it would be -2 because it's a shift left, right, instead of to the right, and then it's -3. So there's really two options to graph this, and depending on the directions, you might choose differently. If it said find the intercepts and graph, we're going to do what we just did. But if it just said graph, then I could find the vertex, and I could plug in a point like we did before to the left and the right of the vertex. This time, the vertex, the x coordinate was -2. So if I wanted to plot points, I would plug in like -3 and -1, one to the left and one to the right. But there are going to be times when it specifically asks for your intercept, so you're going to have to learn how to do it this way too.
Can you go over the y-intercept?
The y-intercept, I plug 0 in for x. So from this equation, clear that off, I make this 0. So it'd be 0 plus 2 squared minus 3. 2 squared is 4, minus 3 is 1. So y-intercept 0 becomes x, and x-intercept 0 becomes y. Kiara.
For this question, would the answer just be the graph?
It will ask for specific parts of the graph. If it just said graph, yes. But it will usually ask for the vertex, the axis symmetry. It's going to eventually ask for domain and range. We'll get to that. It could ask for your intercept. So it just depends on which each question asks. I want to say, if I remember the website correctly, there's multiple parts to each question.
Thank you.
You're welcome. And there will be, like, your quiz on this is going to be multiple part. All right, now, yeah.
Is it on paper or?
The quiz will be on paper. Yeah, there's a lot of graphing involved. Now this is in quadratic form, right? It's not in standard form, so I can't just pull out the h and the k. This, I have to do negative b over 2a. So I'm going to do x, the h is equal to negative b over 2a. So here's my b. B is negative 6, which means negative 6 would be 6 over the a is 1, so 2 times 1 equals 6 over 2, which is 3. That's the x coordinate of my vertex. God bless you. Then I'm going to take and plug that back in to get the y coordinate. So then I get y equals 3 squared minus 6 times 3 minus 14. Y equals 9 minus 18 minus 14. Y equals negative 9 minus 14, which is negative 23. Yep.
Why can't we do it the way we did it in the last?
So the way, look at what your format is, right? There can't be an x squared and an x. It's not in standard form anymore. So we're going to eventually complete the square. And then you force it into it. And then you can do it that way. Yeah. All right, so now I've got a vertex that's 3, negative 23. So I'm going to say, like, let me go by 2's here. So this would be negative 2, 4, 6, 8, 10, 12, 14. This would be negative 16, negative 18, 22, negative 24. So 3, negative 24 would be like, oh, which 23? Sorry. Would be all the way down there. This is going to point up, so I know it's going to cross the x-axis. There are going to be x-intercepts. I know it's going to cross the y-axis, so there are going to be y-intercepts. So I could solve it that way. Or I could plug in 2 and 4 and see where those coordinate points are. So you've got options here because it didn't say specifics. If it had said find the x-intercept, I would make it 0 equals x squared minus 6x minus 14. And how do I solve that? God bless you. You can force it to complete the square. You could do the quadratic formula. So those are your two options if it's not factorable, which it's not, right? There's no factors of negative 14 that sum to negative 6. So I could do quadratic formula. In a minute, we're going to review complete the square because that's your other option. So negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. 6 plus and minus the square root of 36 plus 56 over 2. 6 plus and minus the square root of 92 over 2. (92) becomes 2 and 46, 2 and 23. So this is 6 plus and minus 2 square root 23 over 2. Simplifies to 3 plus and minus square root 23 over 1. So I don't need it. So those would be my x-intercepts. 3 minus square root 23, 0, and 3 plus square root 23, 0. How do I graph those? Good. So square root 23 is close to what? What perfect square? 25, but it's a little bit less. So this could be like 3 minus 4.8 and 3 plus 4.8. I'd get negative 1.8 and 7.8. So negative 1.8 and 7.8 are where it crosses the x-axis.
What was it? The 7.8 were you?
I did 3, so this is what I got from my intercepts from the quadratic, and then I approximated root 23 to be like a little bit less than 5, so like we said 4.8. And then it's 3 plus 4.8 and 3 minus 4.8. It's from this part of my quadratic, yeah. All right, and then the last thing, and here's the good news. This is the easiest thing you get of all of them. The y-intercept, when it's in quadratic form like this, x squared minus 6x minus 14, this would be 0, that would be gone. This would be 0, that would be gone, which means the y-intercept is 0, negative 14. It's the easiest thing to find, the y-intercept when it's in quadratic form, because you literally ignore the x's and go straight to the c term. So that's negative 14, which is where it's going to cross the y-axis. And then I connect my points. Oh, that's really rough, but you get the point. Questions on that one? If it didn't ask for your x-intercepts, you could also just plot a point to the left and the right of the vertex. So if it didn't ask for it, I'm like, we're doing it to practice it, but if it doesn't ask for it, then you could literally just have plugged in positive 2 and positive 4 and then seen where those coordinate points were, okay? You can also do it that way. Most likely it's going to ask for your intercept, so that's why you want to get to practice those.
On the test or quiz, if you go on 3 points, you just
So on the quiz, we haven't gone to test yet, but on the quiz, it's going to be like multi-part like that. Like it's going to ask you for the vertex, going to ask you for the axis symmetry, domain, range, intercepts, all that stuff. Yeah. All right. Let's do it one more time. So can I use the HK from my equation in this one? Can I just pull out the HK? No, it's not in standard form. Kiara.
For the other one, when it's like a radical and it's like an estimate, how would you graph that? Like on the website?
I don't know if it does, actually. Good question. Let me look at it. Okay. You might have to plug in to find the exact point. So you might have to just plug a value in. I'll look at that while you're doing it. Okay, so I know I can't just go HK. What's the first thing I'm going to do? Negative b over 2a. So b is 6, negative 6 over 2, a is negative 1. Gives me a negative 6 over negative 2, which is positive 3. That's the x coordinate of my vertex. I'm going to take that and plug it back in. So negative 3 squared. Now that 3's in parentheses, and that's important because we're going to multiply it, or we're going to square it, and then take the negative. So this becomes negative 9 plus 18 minus 8, which is 9 minus 8, which is 1. There's my vertex. 3, 1. Then it says axis. It means axis symmetry. What's the axis symmetry? It's x equals 3. Good. X equals the h, or the x coordinate of your vertex. Now I need x-intercept. So for x-intercept, I'm going to make y 0. Can I factor this? What could you do first to make your life easier? Divide by negative 1. Because it's equal 0, I can divide or multiply everything by negative 1. Make it look pretty like we're used to. Are there factors of positive 8 that sum to negative 6? Yes, thank God we don't have to use quadratic again, right? 0 equals x minus 2 and x minus 4. Then split and solve, and I get 2 and 4. So my x-intercepts are 2, 0, and 4, 0. And then, quick, give me the y-intercept. Negative 8. 0, negative 8, right? We ignore it, we take the negative 8. Only if it's in standard form. So now I'm going to plot these points. I'm going to go 2, 0 and plot a point. I'm going to go 4, 0 and plot a point. And I'm going to do negative 8 once it's down here. And then I connect them. Not so bad when it's factorable, right?
will quadratic work for every single time?
Yeah.
So you don't have to really have to complete the square at all, right?
Oh, you're going to be forced to complete the square. Yeah. Because it's going to say put it into standard form, so you're going to have to change the equation from one to the other. Yeah. All right. Here. Even this is factor. Okay. This is your other attempt. So if it's in standard form, I would leave it in standard form. I would pull out the HK. I would find my intercept. So that's when it's like in parentheses raised to a power, much easier to deal with. If it's in quadratic form, so if it starts with an x squared and an x, you have two options. One is the negative b over 2a that we already did. Negative b over 2a, find your intercepts or plot points. That's one method. The other method is forcing it into standard by using complete the square, okay? So we are going to take an equation that is like this, and we are going to complete the square. We're going to do it a little bit differently than we did the last time because we want it to stay equal to y. So I don't know if you remembered, but we set it equal to 0 last time. So we could make changes like multiply everything by -1 to get rid of a negative. We could make changes like get rid of fractions because it was set equal to 0 because we were solving it. Now it's a little different. So the first step is going to be to group the ax squared and the bx together. That's the same we used to do. If that a is not 1, we have to factor out the a. You can no longer divide all your terms by a. So that's where it gets to be a little bit different. We're going to rewrite it with the a on the outside. Then you're going to complete the perfect square trinomial like you did before. You're going to take the b, which is the middle term, divide it by 2, and then square it. You're going to add that term to inside the parentheses, and you're going to subtract it from outside the parentheses. So last time we did this, we added it to one side and added it to the other side. Now we're keeping it all on the same side, so the balance is adding to the middle and subtracting from the outside. If you took something out of the ax squared plus bx, then you have to multiply that term by that first. So I don't know if you remember, but I taught you both ways, and I said it was way easier just to get rid of that stuff. You can't do it anymore. You got to do it the first way. Then you're going to factor the perfect square trinomial. That doesn't change. And then your function would then be in standard form. So you're forcing it into standard form. So we're going to work through these. It says put the equation into standard form. This means complete the square. And then find the vertex, the y-intercept, the x-intercept, and the axis. So first step is group the first two terms together. Bump the 3 to the outside. We're not adding that to the other side this time because it's not 0 on the other side. We want to keep y by itself over there. I take and look at the x squared term. Is there a number on the front? No. If there was, I'll factor it out, which we'll practice that. So then I go straight to b. I take 6, divide it by 2, and square it. 6 divided by 2 is 3. 3 squared is 9. I'm going to add it here. Now I don't want to put it on the left side, which means I'm going to have to balance by subtracting it from the same side on the outside.
How do you do -6 instead?
You can. You're always going to square it, so it won't matter. Yep. So now I get y equals, I square root the first term. I square root the last term. I take the sign from the middle, put it in the parentheses and square it. And then -3 minus 9 is -12. Now my equation is in standard form. What's the vertex? What's the first coordinate? You got the -12, but what's the x? +3, good. And the k, which would be the y, is -12.
Didn't you flip the signs?
No, just think about it like when you go to graph using transformations, you only move the opposite direction of your parentheses, right? Outside, you follow what it says. That's kind of the concept. So you change the sign on the h, but you don't change the sign on the k. Then I want to find the y-intercept. So I'm going to make 0. I'm going to make x 0. I can either do it here or I can do it here. What's the perk of the first one? It just cancels right out, right? So always go from here to find the y-intercept. Y would equal, this would be 0, 0, -3. So I've got vertex, I've got y-intercept. Then I do x-intercept. If it's factorable, I would say go from the original, but there's no factors of -3 that sum to -6. So it's going to be easier to do this from complete the square, okay? So I'm going to use this one. So I make y0, x minus 3 squared minus 12, add the 12, square root both sides. I get plus and minus, this would be 4 and 3, so 2 root 3 equals x minus 3, and then add the 3. 3 plus and minus 2 root 3. So I get 3 minus 2 root 3, 0, and 3 plus 2 root 3, 0. And then the last thing it wants is the axis of symmetry, which is what? X equals 3. Good. X equals 3. Always the h or the x coordinate of your vertex. It has to be x equals though, because it's an equation. It's not just 1 point. It's an equation, so it's got to be x equals. If it had said to graph it, obviously I would graph it. You're going to have to approximate these. God bless you. And when you, like if I was to go and approximate 2 root 3, it would be easier to approximate it as though it's square root 12. So keep that in mind. When I write the answer, I would write it as 2 root 3. But when I go to graph it, it's easier to do that from root 12. I would approximate root 12. But this didn't say to graph it. It just said put it in standard form. Yep. You're gonna, so for the intercepts, you're gonna have to keep it exact. For the graph, wait, it's loading. So this is example 16. Put the equation in a standard form, then find the vertex, y-intercept, x-intercept, and axis. So again, this is complete the square. Step 1, group together the 2x squared, the minus 3x, bump the 1 to the outside. Now I got to do what? Take the 2 out. Ew. This gets divided by 2, so it's gone, but this gets divided by 2, which means my middle term is minus 3 over 2x. We can't divide everything by 2 because it's not 0 on the other side, so it wouldn't go away. Now, my b is negative 3 over 2. I don't need to keep the sign, but I'm going to take the 3 over 2, divide it by 2, and then square it. So 3 over 2 divided by 2 is the same thing as multiplying by a half. That's 3/4, and 3/4 squared is 9/16.
Can we leave it as 3/4 squared and then put it in?
Yes. Yeah, because you're going to end up having this, but on the outside, no.
Yeah.
So you're going to have to add 9/16 here, but if you wanted to leave it as 3/4 squared for that, that's what you mean? That's fine. You just have to now subtract 9/16 from the outside. But because I took out a 2, so normally I would subtract the 9/16, but I took out a 2, which means I have to multiply that by the negative 9/16 first, which makes this minus 9/8. So if you took something out on the front, you have to multiply it by whatever you would normally subtract from the outside before you combine it. Now I'm going to rewrite this because it's a mess and hard to read. X squared minus 3 halves x plus 9/16. And then the end here is 1 minus 9/8, or 8/8 minus 9/8, which is negative 1/8. Now we factor. Y equals 2 square root of x squared, square root of 9/16, sign from the middle, squared minus 1/8. There's my standard form. What's my vertex? Good. What's my axis symmetry while I'm on it? X equals negative 3 over 4. No, sorry, positive 3 over 4. Okay, y-intercept, plug it into the beginning, remember? Because it would cancel, it would just be 1. So y-intercept, 0, 1. X-intercept, I'm going to check if my initial is factorable. Are there factors of the first and last, or are there factors of 2 that sum to negative 3? Yep, so I'm going to factor it. So I'm going to do first times last. 2 times 1 is 2. Factors of 2 that sum to negative 3, negative 1, negative 2. Plug them in. Factor by grouping. And I get positive 1/2 and positive 1. If they weren't factorable, you'd have to use quadratic. Or you could use, which I would probably, sometimes it's easier, sometimes it's not. It gets messy when you've got the numbers on the front and the fractions. You could use either one. So you kind of have that choice at that point.
So for x-intercept, you just plug in 0 to y?
Correct. So on the homework, a lot of them in the beginning, like almost every single one, I think, actually, hang on, let me go all the way back to the beginning. It says, yeah, so the very beginning ones are like our very beginning ones, where you're just taking your equation, you're using kind of transformations, and then plotting points. When you get to the second one, the very first thing it says is to take it in and put it into standard form. So you're going to have to complete the square, then find the graph, then answer vertex, axis symmetry, x-intercepts. And then you go to the next one. It's complete the square first, then sketch the graph. So every single time you're going to get asked to complete the square and then find your graph based on it. You're going to want to hand draw these. So when I look for the homework on these, I'm going to, except for the ones at the beginning that are just based on transformations, like except for number 1, you need to make sure that you're practicing the hand-drawn part of this. This homework is not going to be due until Monday, but my advice is to make sure you at least start it tonight so that you can come in on Friday with some questions, okay? So grab at least a couple. The ones that say find the equation, we have not done, so don't do those yet, okay? That would be like from 12, 13, and 14. So skip those for now. Skip 12, 13, and 14 for now, okay? That will be what we finish up on Friday in addition to some extra practice. Everything else you can at least attempt. I'm not saying you have to finish all of them because it's a long assignment, but you can at least attempt the rest of them.
How do you find the axis of symmetry?
X equals H. So whatever the X coordinate is of your vertex, it's X equals that. And it has to be an equation, and I don't think it gives it to you. You have to type it in as X equals. Otherwise, it will mark it wrong. Yep. You're welcome.